So first things first, we're going into the yellow lesson objective packet to rate ourselves before the lesson on 1-5 topics of solve and graph inequalities and write and solve compound inequalities. And again, the hope is this is a 2-day lesson. It's kind of hard to remember, I know, but after you watch the video tomorrow, that you'll go back and you'll rate yourself after the lesson, 4, 3, 2, 1, 0, where do you feel you're at? And hopefully see some growth. And then after you do the homework, even more growth. That's the goal. All right, so while you're finishing that up, I better find what page. Oh, it looks like all of you are already there anyway. So we are on page 22 in your note packet. Anybody need more time to rate themselves? Well, then let's start talking about these inequalities. Inequalities, in basically means not. So equalities, the root word is equal. They're not equal. They're less than or equal to, greater than or equal to. Those are the inequalities. So that's what we want to do. And sometimes over the summer, this extended summer for you guys, over those 6 months, we kind of lose what on earth does this thing say? So we're going to start with a review of writing each statement in words and just making a quick little number line graph of what we see. So I know back when I was in school, it was always the alligator is greedy and always wants to eat the bigger number. So here's the alligator's mouth, so the 2 is bigger, so x is actually less than 2. Anybody else learn something in elementary school like that helped them? Is it still the alligator? Is it all these years later? Still an alligator. Okay. Now when we graph it, what we want to do is have numbers on our intervals so that it looks like we know what we're doing. We need a 2, so maybe I do 1, 2, 3. And those intervals always have to be the same length. I can't do 0, 2, 7. That makes no sense. The intervals are the same length. Then we had this whole open dot, closed dot thing. Does this one get an open or a closed dot? 6 months is too long. If it doesn't have an equals bar, then it's going to be an open dot. So we open dot it at 2. And then we remember, this said all the real numbers, because that's what x is, all the real numbers that are less than 2. Well, that's the stuff to the left of it on the number line. So it needs to go this way, and you have to put an arrow to show, going to go this way forever. Now, when you get to college, you'd lose like a quarter of a point on a problem like this. Because at college, the professors want you to put what the variable name was when you go there. We're not going to be that picky, but it's a good habit to see at this point. So if this one said x is less than 2, what does this one say? X is greater than or equal to 5. Whoops, I need to spell greater, right? Greater than or equal to 5. So my number line, maybe I'll do 4, 5, 6. Using logic and what we know about the one we just graphed, does this one get an open dot or a closed dot? Got to be closed, yeah. The last one was just less than, and it got an open dot. This one has the equals bar right there. Closed dot. Where are the numbers that are greater than or equal to 5? To the right or to the left? To the right. Again, show your shading, big arrow. And if you'd like to, since, there's not a lot to do here, put a little X right there. Don't have to, but it helps. All right. How about the next one? What does this one say? Now I'm going to call on people. Let's see. I got to be able to see the names here first. Mason, what does this one say? That's exactly what it says. X is greater than 3. So, 2, 3, 4. Open or close dot, everybody. Open. It doesn't have an equals bar. You shading to the right or to the left? Right. It's greater than. That's where the numbers are bigger. You know, all these years later, my 5th grade teacher was my first teacher that had a number line at the front of her classroom. And every time I do these, I see that number line. It was right up there with 0, right in the middle. You know, it helps. It helps you think math. Next one. What does this say? Emma, what's this say? Yeah, please. Beautiful. That's exactly what it says. So now I think, okay, got to think a little bit of negative here. So maybe like -2, -1, 0. Those would be good intervals. Should we do an open or closed dot, everybody? Closed. It has the equals bar. Where are the numbers that are less than or equal to? Right or left? Which way should we shade? Left. And now they're messing with us. That's backwards. That's not how we want to read it. So we have to remember, because it's much easier for us to understand what's going on if the X is on the left. If we want to flip it, you got to flip the whole thing. You put the X over here, you change the symbol and make it backwards. And the reason we do that is it makes it easier to graph it. You know, that's the easy part. So now it definitely says what, Riley? That's what it says. X is less than or equal to, oh gosh, my Q is getting carried away there, equal to 4. 3, 4, 5. Oh, you know what? No, I'll be different this time. 2, 4, 6. Ha! That's exciting. So my intervals are the same length. They're just going by 2's this time. And you can do that. Open or close dot? Closed. Has an equals bar. We shading right or left? Left. Less than or equal to. Boom. Going that away. So now, that's a little refresher. You know, we can figure out what they say, and then we can graph them from there. So problem 1 says, what inequality represents the sentence, the product of 7 and a number is no more than 50? Oh boy, what's product mean? Product times, yeah. So 7 and some number, did they say what the number was? So we get to use whatever variable we want. I'm going to use an X. Here's where it gets weird. Is no more than 50. Okay, so question. Could it be 50? It's okay to be 50, so it's going to need an equals bar. Can it be less than 50? Yeah, because it said no more than 50. Now, if this part is really hard for you, what you need to do is you need to put a number in here and see if it makes sense. So you start thinking, you know what, maybe it's 49. Is 49 no more than 50? Yeah, it's not even 50. So less than or equal to works because 49 works. So this is called, we're taking the words and we're making them into an inequality, when they don't really say expression, they just say an inequality. So there it is. This one says, what inequality represents a sentence? The quotient, oh boy, quotient of a number in 3 is no more than 15. What does quotient mean? It is division. Quotient of a number, well, I don't know what that number is, I better use x, and 3 is no more than 15. So again, you ask yourself, can it be 15? Yeah, it can be 15. Can't be more than 15, so obviously it can be less than 15. So what I'm trying to do is talk you through different ways of taking the words and translating them into the inequality and getting what you need. Now, I can't have you do the partner thing, we all know that, but in the past, when you have solved equations, is it exactly the same as solving inequalities? We'll just talk together as a class here. So if I solve this and this, are the steps exactly the same as they would be if it were an equation? No, you know there's something hinky, right? Anybody remember the one glitch with inequalities? What's the one hinky thing with inequalities? Remember it? Dividing by a negative. It is. If you have to multiply or divide by a negative, you have to switch the sign. You got to flip it. So this one would be normal. We'd look at this and say, I want x by itself. I'm going to divide by 3. All is good. But you come over here and you subtract your 1. And then comes that big step of dividing by a negative 2. When you multiply or divide by a negative, you have to flip the sign. That's the rule with inequalities. So the answer to their question is no, they are not the same. Now, even if you don't write that down, you know how I give you all those little lines on the right-hand side over there? That's where you want to write. When solving inequalities, if you multiply or divide by a negative number, you must flip or switch the sign. And a big star by that, because that's huge. Always somebody that forgets that on the test, always. If we multiply or divide by a negative number, we have to flip the sign. So everything else is the same. Just like solving all the equations that we've been solving, we just have to watch out for multiplying or dividing by a negative. Cool, that doesn't sound that hard, but then, it's one of those things you forget because you get going too fast. People are writing like crazy, so I want to hang on and make sure everybody had a chance to write down. If you multiply or divide by a negative number, you gotta flip the inequality. Anybody need more time? All right, off we go. And here it is. The one exception, you must reverse the inequality sign if you multiply or divide by a negative. Oh, see at home, you just had me write that down on the other page. Now I got to write it down again. Yeah, because the more times we talk about that and we write it down, the fewer of you are going to get it wrong when we take the test. You're going to remember, oh yeah, I had to write that down twice. Your brain is a marvelous little machine. If you have to look something up once, it says, well, I don't know if I'm going to need this again. I don't want to hold on to that. You look it up twice, you look it up 3 times, your brain starts to say, I'm pretty sick of this. I'm going to remember this thing, so I don't have to look this up again and again and again. If we multiply or divide by a negative, when we solve the inequality, we got to flip the sign, and then boom. Notice there's no box. It doesn't say, do step 1, this, do step 2, this, do step 3. It's like we're supposed to know what to do, because we do. Looking at problem 2, what do your instincts tell you should be step 1? Distribute. Yeah, we want to do that. We don't want those parentheses hanging out there. And that's what happens for most people. Every once in a while I get somebody says, oh, let's divide by 4. Yep, you can do that too. It's up to you. But most people will distribute. Then what are you doing? Come on, some of you are already done. What are you doing? Do we have to flip the sign if we add 28 to both sides? No flipping. Then what would you do? And if we divide by 4, are we going to have to do some flipping? Nope, 4 is positive. There it is, right there. Now it says solve and graph the solution. Well, let's do 1 or 2 of these graphs. I don't think we want to graph all day, but let's do a couple of them. Because I think you pretty much got the gist of it on the last page, right? So, if you answer me how to do this correctly, I'll know we don't need to do lots of graphs today. Open or close dot at 2? Uh-oh, heard both. Open, no equals bar. Which way should we shade? That way, to the right. See people pointing. And there it is. Oh my, God, it looks hard. You think it's going to be hard? Well, let's try it. What are you doing first? Distribute. Yeah, that's what most people do. Be careful with your negative. Now I want you to take a look at it. You see how there's too much gunk on the left-hand side? We like just having 2 terms over there because then we start moving things over. Well, that means we're not done over there. There's some combining like terms that we can do. Because we have a negative 18 plus 5. So you should collect those up before you start moving anything over. Next step. Add 13 to both sides. Do we do any flipping for adding 13? No flipping. Then what do we do? Divide by negative 2. Do we do any flipping for dividing by negative 2? Absolutely we do. Do we need to graph that one? Open or close dot? Shading which way? Okay, let's not bother then. Because this is what we're really after. It's like, how do you use this in real life? And this is definitely one of those things. Many times when you have something that breaks down at home, you just call the first one that shows up when you Google, or one of the first ones you see when you are flipping through the phone book. I still use a phone book, yes. But you can end up just paying through the nose because of that. Did you know that some companies will actually pay the phone company extra to have an extra A in front of their name so it's the first thing that shows up? They do that. There are companies that pay search engines like Google money so that their information comes up before anybody else's. Well, they got to make up for that advertising. They do by charging you more money. So you get at least 2 calls here. You've got a plumber. And you've got plumber A, and they charge $75 just for coming there. And then they get $40 per hour. Plumber B charges $50 per hour, but doesn't charge you that service fee. How many hours must a plumbing job last for plumber A to cost less than plumber B? Well, let's start at the end. Remember how I told you if people have trouble with word problems, go to the totals? Right here it says plumber A needs to cost less than plumber B. So that's how I'm going to start, just by setting that up. Now I'll go back and figure out how much do I have to pay plumber A. So what's something I pay plumber A? Go back and read through it. What do we absolutely have to pay plumber A to get him to the doorstep? Gotta pay the $75. Is that all? No. What else does plumber A get? $40 per hour. 40 for each hour. Yes, I'm going to use H just so that we can keep our brains working on H's number of hours. Again, that's called defining your variable. Now we want to know, when is that less than? Was there a service charge for plumber B? Nope. Okay. So how much an hour for plumber B? 50 smackers, so 50H. When we solve this, we'll be able to answer our question. When is plumber A going to cost less than plumber B? So, what do you want to do? I see you're using the stare at it and hope it goes away method. Is it working for you? It's not working for me. We got to get the H's on one side. Let's subtract 40H. Do we need to do flipping for subtracting? Nope. How are we getting H by itself? Do we have to flip for dividing by 10? No flipping? Oh, don't need the 0 on there. This is in hours. Oh goodness, I put an equals down too. That's because I was thinking I need to tell you that at 7.5 hours, they would both be exactly the same cost. But we didn't want exactly the same cost. Now here's the problem. While we solved that, we put the variable on the wrong side. Well, like I told you before, what we have to do is flip everything so it'll make sense to us. And because it's a word problem, we really need to write a summary sentence here saying, okay, this is what's going on. So if we need, apparently I'm spelling we with 2 E's, that's not good. If we need more than 7.5 hours of work, that would be what we would want to do. So that was going to tell us when plumber A costs less than plumber B. The guy that had the big service fee eventually becomes cheaper. So anything at more than 7.5 hours, you want the guy with the service fee. Yeah. And like I said, you want to call, get 2 or 3 estimates before you do these kinds of things because it can add up to a big, big difference. All right. Let's talk digital music. A digital music service offers 2 subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and charges 50 cents per download. Ooh. How many songs must you download for the second plan to cost less than the first plan? Okay, like I said, I don't generally use S as a variable, but remember, this is just a setup. So go to the very last sentence. Second plan less than the first plan. Now we go back and get all the math. All right, second plan. You don't ever download any music. You still have to pay what? Second plan. You sure do. But you do make some downloads. How much is each one of those downloads? 50 cents. I'm going to use D for download. D is not a horrible variable. First one, you pay what, no matter what? 9 Smackers membership fee. Well, that's cheaper. Well, and then you get to this part. How much per download? $1. So I'm going to put the 1D so I don't lose anybody when they're looking at this later. So we need to solve this. Well, we've got D's on both sides. That's not good. So again, what we do is we usually say, which one of those is smaller, and move it over to the other side. Is 50 cents D smaller than 1D? Yeah, so that's the one we'll move over. And it's subtraction. So we don't have to flip. Boy, did I ever write too big. Then what would we do? Subtract 9. I'm going to have to try and do a little squishing over here. I thought I had more space. 25 minus 9, 16. Then what do we do? Way over here now. How do you get D alone? Divide. So it's up to you. You could use a calculator and do 16 divided by 0.5. I think in terms of fractions. 0.5 is 5/10, which is a half. If you divide something by a half, you really multiply it by 2. And now let's flip it around backwards so it'll make sense for what the question said. More than what? In a sentence, if we're going to purchase more than what? 32 downloads. So, yeah, the membership fee is more, but you don't pay as much for each of those downloads that you do. So, after 32, at 32 they'd be even. So if you're just going to do exactly 32, it's not going to matter. Now, like it says, sometimes inequalities have no solution or all real numbers for solution. Well, how does that happen? When goofy, hinky stuff happens. So you're solving a problem, you're like, I've got this, and then all of a sudden something disappears. Uh-oh. Doesn't mean you're wrong, just means something weird's going on. So this says always, sometimes, or never true. I'm looking at A, and I'm thinking, you guys are going to distribute. That's what you want to do. You could divide both sides by 3, by the way, but nobody does that. We distribute. We were taught in exponential and in pre-algebra to distribute. So that's what we do. And we get here and we say, okay, I'm going to need to move a 3x over. I'm going to subtract 3x from both sides. Oh, wait a minute. 3x minus 3x, that's 0. That's all I have left. So what does it mean? Is this true? Is 9 greater than or equal to 6? Then this is always true. So if we get an inequality that is always true, then really it says, always piece here because they want to connect that to us, but there's going to be infinitely many solutions here. In fact, it doesn't matter what number you put in for x, it's always going to work, is what that says. So this is our always. Our sometimes is what feels normal. X is greater than 3, X is less than -1. Those things feel normal. That's sometimes. Well, we ought to expect this one isn't going to work, right? So let's see. Oh, they got too much gunk on the left-hand side. They didn't simplify that yet. We need to simplify that. So we've got 9 minus 5 is 4 minus x is less than -x plus 4. Okay. Well, I'd want to move my x's on the same side, so I would add an x to both sides. That means they drop out. Is 4 less than 4? No. So again, when the hinky stuff happens and the x's drop out, that's when you have the always or the never situations. It's the exact same thing that happened when we were solving our equations. The x's drop out and we just have to figure out, is this a true statement? Then it's always true. Is this a false statement? Well, then it's never true. And since you guys have been cruising ahead from me, I want you to do the got it, and then I'm going to call on people to help me out with that one. And it's a good thing that you're like ahead. That means you're feeling really comfortable. Quick reminder that steps are points on the test. Don't skip steps. You'll lose points. I think almost everybody is done. Nevaeh, how did you start this little bugger? Distributive? Sounds good. Feels natural. They're looking like that? Okay. Then, Landon, what did you do after that? That's what I would do too. And that's when you got the hinky stuff, right? Okay. So, Ashley, what does that mean? Is that true or is that false? That is absolutely true. So this one would always be true. So, x's drop out. You know something weird's happening. Get to the statement, read it off to yourself. -12 is less than 8. Duh. Yeah, it is. That's always true. Well, that's because it doesn't matter what x you put in. This is always going to work. And I think that's, because this is part 2. That's where we're going to stop today, We talked about word problems. We went through and set those up. And really, the word problems definitely are the part that, as a consumer, you want to be able to figure out who's going to be cheaper. Why does that have 2 pages? Let me double check, because I think The schedule must have been messed up. And again, you know, you're not supposed to use these old assignments on here anyway. But yeah, so just ignore this assignment that's up here and use the one that's on Schoology. It must have been a year where we had to do part of 1-4 and 1-5 together. Yes, that's what it was. And that was because last year we only had one safety day. So this year we have two. So we'll use the one that's on Schoology. I'm going to study. So there's 1-5 day 1. That's more like it. And then tomorrow, you guys will watch the video for 1-5 day 2. I am going to try, because there's no safety day tomorrow, so no fire drills going off or anything. I'm going to try and record again, 3rd hour tomorrow, and then have the new video up.